Well, welcome to tonight's lesson on piecewise linear functions. So you might be asking yourself, what is a piecewise linear function? Well, basically, a piecewise function shows a portion of a function. So let's get that in our notes. Piecewise function shows a portion of a function, and basically it's graphed over part of its domain. So let's go ahead and jot the directions down. We're going to evaluate the piecewise function for the given values of x. Number 1. So I'll give you a moment to copy it down, pause it, and come back when you're ready. So our first goal is to evaluate f of 3. So you first have to decide, are you going to use the top function or the bottom function? And it's pretty simple. You just look at these two inequalities here and determine where 3 falls. Is 3 less than -2 or is 3 greater than -2? Well, hopefully you know that it's greater than -2 and you're just going to evaluate this. So my goal is to substitute a 3 in. So I'm going to pick the function f of x equals -4. And I need to substitute a 3 in. Well, there's no place to put it because there's no x value. So my final answer is just -4. Basically, it's saying y equals -4. For any value of x, y is -4. Let's try the second one, f of -4. So again, I have to determine which piece of the function I'm going to use. Is -4 less than -2? Or is -4 greater than -2? And if you ever get stuck, guys, just picture a number line. Here's 0, here's -2, here's -4. -4 is less than -2, so I'm going to use this top function. So I'm going to say f of x equals x plus 5, and I'm going to evaluate f of -4. So -4 plus 5 is equal to 1. Last one, we're going to evaluate f of -2. Now, which function actually uses -2? The one that's less than or the one that's greater than or equal to? Well, it's the one that says equal to. So I'm going to use the function f of x equals -4. And again, is there any place to plug the -2 in? There's no place to even put -2, so my answer will just always be -4. Let's go ahead and try a second one. So again, pause it, get this one copied in your notebook, and we'll turn it on. All right. My guess is you can probably do this on your own, but I'll walk you through one more. I need to evaluate f of -2, so again, I'm just simply going to say, am I going to use the top function or bottom function? Where does -2 fall? Is it less than 1 or greater than 1? Well, I'm going to say it's less than 1, so I'm going to pick that top function. And then I'm going to evaluate f of -2 simply by plugging -2 into all my x's. So I was at -4 plus 1, I get -3. Well, now that you've got the hang of it, pause it, go do the next two, and we'll compare. Good luck. Well, you can check my work. Both 6 and 1 fell in my second equation, so I just simply substituted them in, and I've got -9 and 1. Check my work out if you need more help there. All right, so now that we've evaluated them, we also have to be able to graph these functions pretty fluently. So here's what I do. I'm going to make a table of values for each piece of each graph. So let's start with the top graph. Oops, top function, I should say. Okay, I'm going to make a table. I have my x values and my f of x values. And in this one, I'm saying f of x equals x plus 5. Okay, so I'm using this top function first. Now, we're always going to start at the breakpoint. And the breakpoint, let's go ahead and label it, are whatever these intervals are about. So it looks like -2 is my breakpoint. So I'm going to start at -2. And then I'm going to pick some numbers that it says to. It says pick x values that are less than -2. So I'm just going to pick like 3 of them. -3, -4, and -5. And then I just have to evaluate them in the function. So when I substitute in a -2 in my function, -2 plus 5 is 3, -3 plus 5 is 2, -4 plus 5 is 1, and -5 plus 5 is 0. So now I know what this function is going to look like. The other thing I should anticipate is that this is the equation of a line, x plus 5, the slope is 1, and the y-intercept is 5. But these are the points I'm going to start with. So let's go ahead and sketch them on your graph. So I'm going to go -2, 3. I'm going to do the best I can here. -2, 3, -3, 2. Let's see, -4, 1, and -5, 0. Now it just doesn't stop there, and that's what you have to continue. It's going to go in this direction forever. Okay? because it says all values that are less than -2. Now the one thing I have to consider is that at my breakpoint, you have to determine if you have an open or closed circle. Now notice it just says less than. So I'm going to make a note right in my table that that needs to be an open circle at that point, -2, 3. So I'm going to put my open circle there, and then I'm going to draw in forever going this way. And that's it. Now we'll do one for the next piece. Let me grab a different color. So I'm going to make a second table, x and f of x, and this time my f of x equation is f of x equals -4. And I'm going to start at my breakpoint, so I'm going to start at -2 again, but this time I have to pick numbers bigger than -2. So picture a number line, start at -2 and go to the right. -1, 0, 1, 2. Okay, now, this function's kind of neat because it's saying the y value is equal to -4. So no matter what I plug in, my y value is always going to be -4. It's never going to change. There's no place to put the x. I'm always going to get -4. So I'm going to start plotting these. -2, -4, -1, -4, -4, -4, -4. Every point is going to be -4. Now remember, it doesn't stop. It goes forever in this direction. And we just want to determine if we're going to be an open or closed circle. And if I look back, it has the equal to, so let's make a note. This is going to be a closed circle. And forever this direction. So we've graphed our first piecewise function. Again, we're just graphing this function over this domain and this function over this domain. All right, let's try another one. You notice this time that there are 3 pieces to the graph. So we have to do 3 separate tables. So I'm going to go x, and the first one is f of x equals 5. And let's see, so we're going to start at -2. And again, we're going to pick numbers that are less than -2. So let me talk about those breakpoints. This time I have 2 breakpoints. My first breakpoint is -2, and my second breakpoint is 6. So we'll come back to that idea, but just keep that in mind. Okay, so I'm picking numbers less than -2. So -2, -3, -4, -5. And no matter what number I substitute in here, is there any place to put these x values? No. The answer is just always 5. And it should make sense, because this is the line y equals 5. So I'm going to go ahead and graph that now. So I'm going to start at, let me just decide if I'm open or closed. Notice it's a less than, so I'm going to put a big open circle there so I remember. -2, 5, there's my open circle. -3, 5, -4, 5, -5, 5, -6, 5. It's going to continue forever in that direction. Okay, we'll make our second table of values. X, f of x equals 1/2 of x minus 6. Okay, now this time you have to start with the 2 breakpoints. So you have to show everybody from -2 all the way to 6. So -2, -1, 0, 1, 2, 3, 4, 5, and I'm running out of room. I'm going to put 6 way down there. I'm just going to carefully plug them in. Half of -2 is -1, minus 6 is -7. Half of -1 is -1/2, minus 6, -6.5. If I plug a 0 in, I get -6. If I plug a 1 in, I get 1/2 minus 6 is -5.5. If I plug a 2 in, I get 1 minus 6 is 5. Whoops, -5. And you can keep going and fill out that table. So I should get -4.5, -4, -3.5, and -3. And those are all the points we want to plot between -2 and 6. Now you'll notice, what type of circles do we need? At -2, it's closed, so I'm going to put a closed circle. And at 6, it's closed, so I'm going to put a closed circle there to remind myself. And let's go ahead and plot those points. I'm going to pause it and plot it, and you can do the same. So I've got my points plotted. And again, no arrows on this one because we are sitting just in between those two. Okay, it doesn't say less than or greater than. You are strictly in between those two, so no arrows. And then lastly, where I can squeeze my table here, I'm going to have x, f of x equals -2x plus 10. And it says start at 6, so I'm going to start at 6. And it says pick numbers bigger than 6. So I'm going to go 6, 7, 8, and 9. All right, and I just need to evaluate those. So that's negative 12 plus 10 is negative 2, negative 14 plus 10, negative 4, negative 16 plus 10 is negative 6, and negative 18 plus 10 is negative 8. Now again, at 6, what type of circle do you want? Open, so keep that in mind, and it will go on forever because there's no ending sign. So let's go ahead, pause it, plot those points, and we'll check again. So I have my dots on there, and I'm going to make a nice arrow all the way down there, because that side does go on forever. Whew. Okay, so you can see that this is a piecewise function. I have 3 pieces of a graph. This first graph is y equals 5, graphed over its domain, 1/2 x plus 6 over its domain, and negative 2x plus 10 over its domain. And just to remind you, this 1/2 is the slope. Does your graph have a slope of 1/2? Does it rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2? This one should have a slope of negative 2. So down 2 over 1, down 2 over 1. And you can verify there. And then y equals 5 should just be a horizontal line. All right, so we've evaluated, we've graphed, but now we have to go backwards and actually write the equation of the piecewise function. So here's how I start. Let's say this graph is called f of x. So I'm going to start with my f of x equals and a nice big bracket. I actually start with the domain first. So let's take a look at this graph on the left. What values of x is it good for? Okay, so the leftmost goes to negative infinity, and the rightmost goes to 2. So I would say this graph works for all values of x that are less than 2. Now notice I didn't say equal to because it's a open dot here, but starting at 2, everybody less than 2, this graph will hit all the x values, so x is less than 2. Now I just need to write the equation of it. Okay, so the first thing I do is I look for a slope and y-intercept, if I can. And the y-intercept is very obvious here. And so let's see, the y-intercept is negative 3. So y-intercept equals negative 3. And the slope I can easily count. Remember, slope is rise over run. So I'm going to, well, the next thing I'm going to do is identify a point that's easy. I would say that's an easy point to get. I would not pick this point because I don't know it exactly, but that falls right in the coordinate system, and I can grab that. I'm going to rise 1 and run to the left 2. Rise 1, left 2. So I would say that's a slope of negative 1/2. Rise 1, negative 2. So my equation already says y equals is negative 1/2 x minus 3. Okay, see if you agree with that. The slope is negative 1/2. Again, if I were to ski on it, I'd be going down, so I know it's negative. Rise 1, left 2. Y-intercept is negative 3. Now I'll write the equation for the second graph. All right, again, I'm going to start with the domain. The leftmost number is 2, and it goes forever on the x-axis this way. That's what that arrow's saying. It goes forever this way. And it's a closed dot. So I'm going to say my x is greater than or equal to 2. And now I'll have to write that function. Now notice, I can't see the y-intercept on this one, so it's not as easy, but I can probably follow it through. So I'm going to start with the slope. I'm going to find a nice point besides this one that it goes through, and I would say right there it hits the corners nicely. So I'm going to rise 2, run 1. Rise 2, run 1. Check the next one. Rise 2, run 1. So I'm going to say this definitely has a slope of 2. Can I figure out the y-intercept? Well, there's several ways to do it. You could kind of just trace it on the graph. Down 2 over 1, down 2 over 1, down 2 over 1. Or you could actually write the equation that we practiced earlier this week. You know 2 points. This goes through the point, this line goes through 2, 0, and it goes through 3, 2. And it has a slope of 2, so I can use the point slope formula. Y minus 0 equals 2 times x minus 2. Y equals 2x minus 4. And that's the equation I'm going to use here, 2x minus 4. I can easily identify 2 points, and I can state the slope, so I'm going to go with that point slope formula. All right, let's try one more, writing the equation of a piecewise function. Maybe we'll just call this one g of x this time. So I'm going to start with g of x equals, nice big bracket, and notice I only have 2 lines, so I only have to write 2 pieces to the function. Let's start with the domain on the left. Pause it and see if you can write this domain down for this graph that I'm circling. I'm going to say the x values have to be less than negative 1. Did you agree with that? -1, it's an open circle, and then I'm using everybody to the left of it. While I'm at it, I'm going to write the domain of this function. I'm going to say the x value starts at 1 and goes forever this way, and notice it's a closed dot, so x has to be greater than or equal to -1. Now I just need the equation of the two. Again, I'm going to start with the graph on the left here, and I'm going to find its slope. I can easily count, let's see, here's a nice point, here's a nice point. So I'm going to rise 1, run 1, rise 1, run 1. But notice I'm running to the left, so I'm going to say that has a slope of -1. Now again, you could probably count the y-intercept backwards and see that 1, 2, 3, it has a y-intercept of -3. Or if you get stuck, we'll use that point slope formula. I know a point on the graph is -2, 1, -2, -1. So I can say y plus 1 equals -1 times x plus 2. So y plus 1 equals, -x minus 2. Subtract that 1 over, and I get -x minus 3. So -x minus 3 when x values are less than -1. I'm going to go ahead and do the same thing on my second graph. Now this one's a little easier because I can see the y-intercept is 2. And I'm going to count that slope. I'm going to rise 2, run 1 to a nice point, rise 2, run 1. So I'm going to say that has a equation of 2x plus 2. And there you have it. We've written the equation of that piecewise function. Well, I think that does it for us tonight. We look forward to any questions you have. Feel free to come in the morning and ask, and we'll see you tomorrow.